Hello, HA students, here with our third lesson, solving absolute value equations and inequalities. We'll still follow that same kind of agenda here in terms of first five getting us going and recapping our last lesson unit, our last lesson and assignment, and then our new lesson and some work time and convening for the last 5 minutes. You can be ready to share the idea of what do you know about a topic. Here's some voices here. Try not to put you on the spot too heavily, but just be present. Again, our general class structure will be the same. Quick review of the solving equations and inequalities from last lesson here. As we look at this first one right here, again, the only thing on the right side of the equal sign is the -11. This is an equation, but we do have some like terms here with some x's, so I'm going to combine those x's. So I have -4 and +7, which overall is a +3, equals -11. And again, now I want all the x's on one side of the equal sign and all the non-x's on the other. So I'm going to take that 1 and subtract it from both sides. Okay, so that gives me 3x equals, now it's -11 minus a 1. So I'm down $11 and I lost another one. So I'm now down $12. And then again, I want to undo the 3 that's multiplied to the x. So to undo that multiplication, I'm going to divide. And so now I have just x alone on the left side. And I have -12 divided by 3, which gives us a -4 for the right side. So -12 divided by 3 is x equals -4. Okay, so now we've got an inequality one down on the bottom. Inequality here, we first of all have to be careful because we have a fraction as well, but we also have to deal with this inequality. So let's just look at this here. We've got the -3/4 x plus 5 is greater than 14. Well, again, I want the x term alone on this side, so I'm going to move that 5 over. Actually, I did change colors here, so I'm going to move that 5 over. So now I have -3/4 x is greater than 14 minus 5, so that's 9. Now, I need to get that -3/4 x to just be x. So how do I get rid of that -3/4? Well, to get rid of that -3/4, the rule is actually to flip the fraction and multiply. Okay, so what we have here is we have a -3/4. Well, a negative times, if we multiplied it by 4/3, would still be a negative. We want it to be a positive. So this is going to be a negative times a negative to get it back to be a positive. So what I'm going to multiply by here is -4/3. Now, top times top is -4 times -3, which is 12. Bottom times bottom is 3 times 4, which is 12. So 12 over 12 is 1. So that would give us just x. So that's great. Now on the right side, we have to multiply by -4/3. Again, multiplying by a fraction now, it's like this is 9 over 1. So that would be 9 times -4, which is -36, over 1 times 3, which is 3. So it ends up being x on the left side and -36 over 3, or -12 on the right side. But one other thing that we have to think about, we multiplied by a negative. And when you multiply or divide by a negative, it changes that sign. So instead of being greater than, it's now a less than. So this is less than -12. So if we were to put a value in to this, let's say -20, -20 when multiplied by -3/4 would be a -15. Okay. Should be +15, -20 times -3/4. So it's a negative times a negative. I got scared myself there. So it's a +15. 15 plus 5 is 20, and 20 is more than 14. So what I did is just placed a -20 in for x here and calculated. Okay, and again, 3/4 of 20 is 15, and it's a negative times a negative if it's a -20 there. So that becomes a positive. And then I added 5, and that was more than 14. So now what if I put in 0? Well, if I put in 0, then negative 3/4 times 0 is 0. 0 plus 5 is 5. 5 is not greater than 14, so that wouldn't work. So it's good that this did not include 0 because 0 did not work here. So again, multiplying by the negative changes that sign. All right. Now, next lesson here, new lesson, is the absolute value lesson. Okay, so absolute value is one big thing you have to think about here is that absolute value is really distance. So it's really never negative. It's just a different direction. So if you think about if you're standing here, whether you walk this way 5 miles, okay, which you might consider in the positive direction, or this way 5 miles, which you might consider in the negative direction, you are still 5 miles from where you started. Okay, so that's what absolute value is really looking at. Is it's not saying you went in the positive or negative direction. It's just saying you've moved 5 miles. Okay, so that's the big thing is the absolute value of 5 is 5, but the absolute value of negative 5 is 5 because it's really about how far have you moved. Okay, so what would this answer be? Well, the absolute value of 7 is 7, but also the absolute value of negative 7 is 7. Okay, so again, in order to have moved 7 miles, we could have driven 7 miles forward or 7 miles backward. It's still that we moved 7 miles. So there are two possible answers to this, and that's what you'll see a lot in this idea of just absolute value on its own, is that there's going to be the negative and positive version of that value, which will equal 7 here. Okay. Now, when we look at equations with absolute values, so we've got x minus 1 equals 8. Well, what does that mean? That means that x minus 1 could equal 8, okay? But because it's absolute value, the x minus 1 could also equal negative 8, okay? Because all that matters is that the inside the absolute value that it is equal to 8 or negative 8 because, again, the absolute value of negative 8 also equals 8, just like the absolute value of 8 equals 8. So we just need that inside of the absolute value, the vertical lines there, to equal negative 8 or 8. So in order to equal negative 8, well, we add 1 to both sides. So that would mean x is negative 7. Okay, so if you look at this, if x were negative 7, then negative 7 minus 1, so you're $7 in the hole, and now you lose another dollar. Now you're $8 in the hole, but the absolute value of negative 8 is 8. Okay, similarly, if I add 1 to both sides here, okay, again, these are two different equations now. Now I've got x equals 9, which if x is 9, then it's 9 minus 1, which is 8, and so that works out as well. So my answer here, if this is 0, is actually going to be negative 7, or it's going to be 9. Okay, so x equals negative 7 or 9. Okay, now this right side is a little more complicated, but not much, because what we do here is we've got this negative 3 on the outside. Well, we just have to get rid of the negative 3 right out of the gate. So right now the negative 3 is multiplied by the x plus 2. So to undo multiplication, we just divide. Okay? And what's done unto one side must be done unto the other. So we're going to divide both sides by negative 3. When you do that, now what's left on the left side is just the absolute value of x plus 2, okay, because the negative 3 divided by negative 3 is just 1. And now on the right side, you've got negative 18 over negative 3. So 18 over 3 is 6, but a negative over a negative, now negative over a negative is a positive, so that is also 6. So this is 6. So I'm going to move down to the bottom down here to give myself a little more room. But again, because this is the absolute value equals 6, that means x plus 2 could equal negative 6, or x plus 2 could equal 6. Okay, so I subtract 2 from both sides there. So that means x could be negative 8. Or if I subtract 2 from both sides on this one, that means x could be 4. So there it is, x could be 4 or -8. So if I put this on the number line again, okay, if that's 0, that means I could end up with a -8 way out here, and that would work. Or I could end up with a 4 right in here, and that would work. If you put these values in, let's see what happens. If I put them in, -8 plus 2 is -6, but the absolute value of -6 is 6, so it's 6 times -3, which is -18. If I put the 4 in, 4 plus 2 is 6, 6 times -3 is -18. So both of those work. So that, again, is the OR situation because of the absolute value. Okay, let's look at a couple other examples here that are a little more unique. One here is this first one. Hopefully that rings some alarm bells for you to have an absolute value that ends up equaling a negative number. This is impossible. There's no way we could do this. If we put a 5 in there, 2 times 5 is 10, absolute value of 10 is 10. 2 times -5 if we put in there, which seems like it could be the answer. But again, this needs to be absolute valued still. So that would be 10. So we can't get that. So we would say no solutions in that situation because there is no possible solution. So no solutions is all you would need to say in that situation. You would leave it at that. Now down here, when we pull that 2 out, in this case, make it a -2, now this becomes a little more plausible. Again, if it's outside of the absolute value, then we're going to get rid of it first. And to undo this multiplication, we're going to divide. So we divide both sides by -2. So that just gives us absolute value of x on that side. -10 divided by -2, so 10 divided by 2 is 5. Negative divided by a negative is a positive, so that is 5. So it's simply x equals -5 or 5 for that one. Again, because we just had that -2 on the outside, and because it was a -2, that allowed that value to end up being positive since it was -10 divided by -2 there when we divided on the right side. So there's just a couple more examples. Now, what if we add in an inequality here? So now we've got the situation of greater than or less than. Now, one thing you have to think about here is greater than means we are further than 7 from where we started. Okay, so if you think of this, we're greater than, from where you stand, greater than 7 miles either way, which means we're 7 or more miles one way or 7 or more miles the other way. Okay, so what this would look like then is x would need to be greater than a positive 7, or x would need to be less than a -7. Now keep in mind, if this is our 0, and this is 7, and this is -7, now we're saying we have to go the open circle there because it's greater than, not greater than or equal to. So there's greater than 7, and then there's the open circle, and there's less than -7. So again, that means we are more than 7 whatever miles, let's say, from where we started. Now that or is very intentional in this case, that it's one or the other. So it kind of goes, and I'll show you here in a moment, but it's almost like we have great or, okay? Because it's, in order to be greater than 7 from where we started, it would have to be further than 7 from 0, which would be 7 or more in this direction, or 7 or, excuse me, more than 7 in this direction, or more than 7 in this direction. Now, when you look at it the other way here, as a less than, you can see it's and. In this case, we got to be within 7 from where we started. Okay, so you can kind of see here that it doesn't matter what direction we go, whether we go in the positive or negative direction, but we've got to stay within 7 miles or whatever of where we started, less than 7 miles from where we started. So in this case, we have x is less than 7 and x is greater than -7. Now, here's the reason it's not an or. If this were an OR here, and I started up here at 7, and I just said x had to be less than 7, well, that means it could go forever. Okay, if it just had to be x is less than 7 or something else, that means, well, that means all of this still counts down to negative infinity. So I could be at negative 500, but that can't happen here. So what we essentially have here is x is less than 7, but we also have x is greater than negative 7. So here's negative 7, and that goes on in theory forever. So our answer here is the and, which is what follows the rules for both of these, which is being within 7. So the answer here is actually negative 7, x 7. Negative 7 is less than x, which is less than 7, which just means that x has to be somewhere within 6.99999 either direction from 0 in order for the absolute value to be less than 7. So that's why we have an and, because an or here would mean basically that it's all possible values, because these blue and red lines here cover the entire number line if they were to go on forever. So that's why we have and. So we'll talk about this momentarily, but this is kind of like less than, because this is less than. In this case, it was great or, and that was that one there. Okay, so what's the difference between the equation and the inequality? We're seeing a little bit there with the or and the and. The equation, again, being the equal sign, is more about solving for an x and saying that x would equal something and maybe or something else in the equation. The inequality, though, is about x being greater than or less than, and again, it could be an and, it could be an or, and so that continues on here. So when we look at this equation, I shouldn't say equation, when we look at this inequality here, where x minus 1, but in the absolute value is greater than 8, that would mean that, again, we're greater than 8 in the positive direction, or we're less than negative 8 in the negative direction because of that absolute value. So from here, we actually set up two equations. We have x minus 1 is greater than 8, or we have, in this case, x minus 1 is less than negative 8. Okay? And so what you'll see here is when I add 1 to both sides, that means x has to be greater than 9. Over here, I add 1 to both sides, and that means x has to be less than negative 7. So if this is 0, here's 9, here's negative 7. I'm saying that my answer here is basically a circle at 9. Again, an open circle because 9 isn't included, and that goes on forever. My answer here is less than negative 7. Sorry, that's a negative. So I'm going to have an open circle there again, and that goes on forever. Now, when you put this back into the equation, you can see why this works. If we were to put 9 into the equation, 9 minus 1 is 8, which of course is not actually greater than 8. But if I were to put a number in greater than 9, say 10, if we were to put in a value greater than 9, say 10, in that case, 10 minus 1 equals 9, which of course is greater than 8. So that would be a win there. Okay. Now on the other side here, with this other one, if I were to put in negative 7 minus 1, but again, absolute value. So negative 7 minus 1 is negative 8, but its absolute value is 8, which of course is not greater than 8. But if I were to put in something less than negative 7, say negative 8, which is less than negative 7 over here, minus 1, well, negative 8 minus 1 is negative 9. Again, you're $8 in the hole. You lost another one, so you're $9 in the hole. Well, that equals 9 when you take the absolute value, which is greater than 8. Okay? And finally, if I were to say test 0, in this case, 0 minus 1, if I were to put 0 in for x here, that's negative 1. Absolute value of that is 1, which of course is not greater than 8, which follows with what we said, that 0 would not be an option, as would any value actually between negative 7 and 9 inclusive. Negative 7 doesn't work, 9 doesn't work, and anything in between, but anything outside does. And again, you could check this by checking one value over here, one value in the middle, and one value over here, just to make sure you're right by plugging them back into the equation. Here's one a little more complicated, but again, you can make it pretty kind if you First, get rid of that -3. So that -3 thankfully takes this to a positive value on the other side. So now we just have x plus 2, absolute value, is now wait a second here, what do we do? Well, we divided by a negative, and when you divide or multiply by a negative, that switches the sign, okay? So that's one you got to be careful with, because if we didn't switch the sign here, we wouldn't get this to work out properly. So this has to be greater than or equal to -18 over -3 is a +6. Now, the reason we changed the inequality is because we are looking at now being at least 6 away, instead of being within 6. Okay, so when we divided by this -3, that changed the whole kind of direction of the question, if you will. And so now when we look at this, we're saying, I'll move it just down here, x plus 2 is greater than or equal to 6, and x plus 2 is less than or equal to -6. Okay, and we do that again because of the absolute value. Okay, so a lot of things going on here. So first, we divided by a negative, so that changed the sign. So this went to this. And then we had to deal with the absolute value, which means we keep the greater than or equal to 6, and we have to look at the negative side of this as well, which again is less than or equal to -6, because we're talking about being more than 6 away from where we started. Okay, and if we started at 0 here, then being more than 6 away would be 6 or more, or -6 or less. So we subtract the 2 from both sides, and we get x is greater than or equal to 4. Okay, so we put a 4 here, and it's greater than or equal to 4. So that goes there. We subtract 2 here, and we get x is less than or equal to -8. And so we'd put the -8 out here, and we'd fill in a circle there and fill backward from there. Now again, you could throw a 0 back into this equation up top. So if I were to put a 0 into this equation, -3, 0 plus 2. Well, that would be -3, 0 plus 2 is 2, absolute value is 2. That's -6. Well, -6 is not less than -18, so 0 doesn't work. So that's good that 0 didn't work. What if I were to throw a 5 in there? Okay, so 5's over on this side, so if I were to put a 5 in there, -3, and then I have 5 plus 2, that would be -3 times 7, which is -21, which is less than or equal to -18. So that's a win. What if I were to put, lastly, -9 in there? Okay, if I were to put -9 in here, now I'd have -3, and then I'd have a negative, and again, I'm over here now, -9 plus 2. So that'd be -3 times, well, -9 plus 2 is -7. Okay, absolute value of that is 7, so that would be -3 times 7 would be -21. So in that case, again, we are less than or equal to -18 from the original equation, so that would be a win. Had I left that negative in there, okay, had I not made this a positive, then we'd be talking about an absolute value needing to be negative, and that would be, again, an issue, as we saw on the equation side. Really, all absolute values are greater than negative because they're at least 0. None of the absolute values would be less than anything negative because they can't be negative. So less than and great or is just a couple kind of statements to keep in your mind. Less than, again, means that the idea is we're within a certain amount of the middle. So we're going to end up with a lot of answers where we have something like this going this way and something like this going this way. And it has to be and, because if it were or, they'd cover the whole space. And that happens every once in a while, but a lot of times it does not. So this is our and, in which case we are not going to include this as these arrows continue on in either direction. We're not going to include that. We're just looking at the space in between them. And again, great or is the idea where you'll typically find being at least a certain distance from where you started. And so in that case, it's really tends to be a positive going to the right or a negative going to the left, or something along those lines. It could technically be a positive and a positive or a negative and a negative in certain cases. But that's where this comes into play. All right. Again, we'll follow this here, and at the end of the lesson, get to the formative work, and then reconvene at the end. So, how do you feel about this? Would be a big thing to ask right now, and then the assignment that comes after this is going to be this Unit 1, Lesson 3 worksheet, which is the absolute value equation and equality worksheet. Try and finish that today, and hopefully have that ready to go for our next class period. Thank you for watching and listening. As always, if you have any questions, please ask.